That's okay. So, bringing it back, combining functions. And again, this is a review of 2.3.2, which we did this before in October. If I'm given two functions, f of x and g of x, which we're going to use for these first examples, and then this function tells me what does, I bring it back, what does this function tell me I need to do? F plus g of x, right? So what do you think I should do with my f function and my g function? Add. So I'm going to take my f function, x squared plus 2, I'm going to add it to my g function. And this is going to be really straightforward. We get, through combining our terms, f plus g of x is equal to that trinomial. Okay, so this isn't anything super tricky. The reason why I want to start with this for our midterm review was basically there's a bunch of different skills we want to have really refined before we get into Unit 3. This is one of them. Combining like terms, this first one's pretty straightforward. How about the second one? What is going to be different between the first and the second?
It's negative, or minus.
Yeah. So this operation tells us what we're going to do with the two functions. It's going to be f minus the g function. So I'm going to write this out. I want you to tell me why I write it this way. Actually, don't tell me. With your neighbor, just one person next to you, really quick, like 10 seconds. Why is it important that I put parentheses around that second expression? 10 seconds, go. All right, good, good. Looks like we got it. Who's confident could tell me why I need to have parentheses there? It's the one crux, I mean the one tricky part of this having subtraction. I know you guys talked. You said something to each other. Yeah, right.
So you have to distribute the negative and outside.
Good. If I do not recall, if I don't remember that and I leave these parentheses out, then it's negative x plus 4. That's going to misguide you. So I put parentheses, and I know that's a baby step, but we need to distribute that negative to both of those terms inside. Okay. Last step, combine like terms. X squared minus x minus 2. And that is our f minus g of x. Right? Distribute the negative, that was the hint, but you know what? We're going to take that away because really the hint is to use the parentheses for our second expression. We did that. Okay. Is this really getting any harder?
The last one is.
Nope.
No? The last one's a little tricky, but we'll work towards that. We're still doing the step 1 approach, which is just combining the functions and simplifying. So go ahead and on your own, you can check with your neighbor after you're done, but what is the function here? Or what operation is going on between my f and my g functions in this case? Multiplication. Okay. So we need to multiply these two expressions together. Go ahead and do that on your own. I'll give you, 2 minutes for that. And I even put a little hint up there as well on how you'll simplify it. Yeah.
Question. Is that right? I'm not sure.
Not. Oh, we can't cross that out. Yeah. That's the one thing. right, let's bring them back together. So I'm just multiplying these two together. I'm ended up with two expressions. Set up like so. Okay. Did everybody set it up like that? Okay. The first step is always setting it up. We have to simplify. When we get to step 2, or our second type of problem, that's where we have to just evaluate, which is plug in a value we're given. But here, I'm going to use FOIL. I'm going to do the first, which is 2x squared times x squared. If you forget what that, or how to approach this problem, one thing that you can do is, one thing you can do is expand it. Remember we did the expand like an accordion, and then compress it. So this is really 2 times x times x. What's x squared? Times x times x. Multiply them all together. How many x's? 4. So we put a 4th. Okay. If you forget how to do the terms, remember that this is our expand method. And the expand method is really helpful for not even recalling that rule. You can like almost invent the rule back, rediscover it if you forget. Okay, that was the first term, and then the second. And the inner and the outer. Combine them out. And we got f of g of x is equal to this trinomial. Why did I put this 4th power first and then the 2nd power? Yeah.
Because you put the higher powers.
Good. Descending order, we start with the higher power. We go down all the way to the constant. Perfect. Okay. Now, this is different for a couple reasons. One, the function, what's going on between f and g? It's division, right? So we have to divide f divided by g. So we got to look at some of those guidelines. But then whatever we end up with as far as combining those functions, we need to evaluate. We need to plug in for 4. So there's a couple ways that we can do this. And I'm going to show you that the path of least resistance might look different for each of them. Sometimes it's going to be easier to simplify and then plug in. Sometimes it's going to be easier to plug in and then just work it out from there. So, well, to start, let's go ahead and put this here. X plus 5 divided by 2x minus 3. Okay. Remember with this, x plus 5 is one entire expression. So you cannot decide that I want to cancel out this x and this x. You can't do that because it's that would entail dividing out of x here and dividing out of x here, which isn't something you can do. On the top, you'd end up with 1 plus 5 over x if you divided it out. So we can't do that method. From here, is there any way that we can simplify this further? No? I mean, you could synthetic division, just make it really delightful. But we're not going to do that. What do you think we're going to do instead next? We're going to go ahead and evaluate it now for 4. 4 plus 5, 2 times 4 minus 3. See, I'm just slowly whittling away. All I did at this point was plug in my 4 wherever there was an x. And let's go ahead and bring it up here. We end up with f of g of 4 is equal to 5 plus 4. Let's see. 2 times 4 is 8 minus 3. 5. So the thing with this, all right. The thing with this is when it gets really complicated. Say if I had, let's even take this example right here. If I had this, and instead of it being just f of g, it was f of g of 2. So I already had it in this configuration. What I'm going to propose here is sometimes the path of least resistance is going to entail evaluating at different stages of the problem. Okay. For instance, this is a binomial, so I could FOIL this out. It's not that tricky. But what happens if we have plus x plus 4? Now that becomes that's a lot of distribution. I have to distribute this, that. Okay. So what you can do at certain stages, it might be just as worthwhile for us to see that we can do this. It might be worthwhile to, let's go ahead and evaluate it right here. See what I did? You can plug in wherever you want. If it makes sense to simplify it first, that's one route. And you'll see what the problems. Number one is a problem where you can evaluate it without simplifying it down. You'll see why. But I worked this out. I'm going to get the same as if I were to FOIL it out. That's going to be 8 plus 3. It's going to be 4 plus 2 plus 4. So altogether, we would end up with 11 and 10. We'd end up with 110. Okay. You see how once you evaluate it, there's no more terms other than constants, other than numbers. You can work it all out slowly using PEMDAS. I started with the exponents. Then I multiplied, I combined each expression, and then I multiplied the parentheses together. Okay. All right, that might not be visible from there. All right, any questions? You see how this kind of flows together? We just have to combine them, and then we have to substitute, evaluate in. All right, thumbs up, sideways, or down for this? Thumbs up. You all ready to go? Great. All right, still looking for that 79th subscriber. So want a Kit Kat or something?